There once was a ship that put to sea. The name of the ship was the Billy of Tea. The winds blew up, her bow dipped down. Oh, blow, my bully boys, blow. Soon may the wellerman come and bring the sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. She had not been 2 weeks from shore when down on her a right whale bore. Captain called all hands and swore he'd take that whale in tow. Soon may the wellerman come and bring the sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go.
All right, welcome back, everybody. We've got another exciting lecture today, synchronous for section 1, asynchronous for section 2. Where are we going with today's lecture? Well, we've got a few goals. First, there's an open warm-up question. If for some reason this link isn't working for you, let me get out of the way here. You can also go to the standard URL that we use in COMP110, which I'll add that to the slide here, and that is polev.com/compunc. Right, so either of those should work. And the active poll, once again, I'm asking for a year. I'll come back and talk about why. I think in a future lecture, we'll be able to use that to potentially segment results to our polls so that we can have some competitions between classes, a battle of the seniors versus the first years. So today we're going to be looking at practicing and reviewing some of the data types and expressions you all learned about over the weekend. Things like strings and numbers, integers versus floats, expressions. All of these are very fundamental and important to being able to program. So having some fluency in these concepts, being comfortable with how they work and how to think about them is what we'll focus on to begin with. And then we'll turn our attention to how to ask the user for some input. And we'll have a follow along coding exercise where we'll make a very simple command line application. We'll also then look at how we can store values in memory using variables. You've already seen variables, but we'll talk about them a little bit more head on in today's lecture. And lastly, we'll take a look at how to diagram in memory. You've seen a preview of this as well, but we'll actually look step by step at what you need to do in order to start producing these diagrams on your own. Before we get into the main material, a couple of quick announcements. As you all know, the first reading went out on yesterday. And this semester, we're looking at responsible computing, which means we're taking a look at what it means to be a computer scientist or a data scientist and being aware of and understanding the effects of the work that we do on, both the people that use our products as well as the society in general. These readings this semester will primarily be focused on the intersections of computer science, data science, and race. And the first paper is one on critical race theory, which is one of many frameworks for understanding and sharing and talking about and having conversations about race and the impact of people's lived experiences. This paper was chosen for a number of reasons. One, it defines some terminology that you'll see commonly not only in the future papers we read, but also in other avenues and discussions around campus as you go into other courses. Also, it was written in 2020 and was selected as one of the best papers in a prominent computer science, human-computer interaction venue. For those of you who are new to the idea of academic papers and how publishing works, the professors that you're surrounded by on campus are frequently working on research as well as PhD students, and they'll take the things that they are thinking about researching and finding, write about them in a paper, and submit that paper to a venue. In this case, it's the special interest group of the Association of Computing Machinery, which is an advanced, very old, the foremost association in computer science for publications and scholarly work. And this one specifically, as I mentioned, was on computer-human interaction, which is a subfield in computer science, which deals with how we as humans interact with our systems and our software and things like that. And this past year, There were over 3,000 papers submitted by PhD students and professors from around the world. And this was one of the top 31 papers that was published, which was another reason why we chose it. It's very accessible, and it's good to have an understanding of what this framework is about. But because this is a difficult subject to engage with, and people have varying levels of comfort, when it comes to responding to the essays, there's 9 possible prompts, one of which is design your own prompt if ours don't feel appropriate to you, and just engage with the material and reflect on how people's lived experiences and technology intersect, which is why we're focusing on this in COMP110. And I think it's very important to be looking at these kinds of ideas and impacts. In the next paper, we'll look at algorithmic bias in machine learning and how algorithms such as even TikTok's For You feed are driven by things that are sort of this mysterious black box, and having some better understanding of how those phenomenon work and what's behind machine learning is worth knowing in today's environment. As a quick update, office hours have been going, and we've loved working with you. Over 120 of you and your peers have come to work with us. If you haven't yet, don't be afraid. We've got a great group of undergraduate TAs ready to engage with you. The average wait time so far has been under 1 minute. As we get closer to larger exercises and projects and deadlines, this can go up. So this is one of the reasons why you're encouraged to start on everything early. You can come for conceptual questions to office hours. This is one of the commonly missed questions on the syllabus assignment. And I don't want to discourage you from coming to office hours with conceptual questions. It's a perfectly great place to come. But you have more time and space to talk about conceptual questions in tutoring once we begin those hours next week. There will be a diagram upload that we'll practice together, and so you'll know exactly what's going on here. But part of getting ready for the quiz, which I'll talk about in just a moment, is understanding how to upload a diagram. So as we're trying to learn how it is that the computer and the Python programming language takes our code and understands its semantics and works through it, evaluating each line, it really helps to have a way of visualizing this and practicing working with this representation, on pen and paper and having a visual for what's going on step by step. Just like kind of working through a math problem and writing out your work, we're going to look at what is the work that the computer is doing behind the scenes at a level of detail that's enough to appreciate some of the harder to understand concepts without getting too into the weeds. When you were diagramming, you were asked to use pen and paper, or if you have an iPad and you want to use that, that's fine. The hard and fast rule is we don't want any typed text if it can be avoided. If you have an accessibility issue for some reason, let us know. But handwriting is preferred. We think that's the best way to learn how to do these. And so as long as you're using a pen of some sort and writing it out, you should be fine. The instructions, which you'll also find a link to on the course site, that will link to Gradescope's specific instructions for both Android and iOS, will walk you through how to set up apps on your phone for scanning documents. The reason for doing this versus simply taking a picture of your documents is these scanning applications can produce PDFs, which are really nice, and they'll also clean up your image such that it feels more like a scan than a picture, and it actually can make it much easier to read on screens. So just like Instagram or Visco or TikTok has filters for improving the aesthetic of that particular use case, when scanning for legal documents, or in this case assignments, it helps to use one of these scanning applications, and it makes it much easier to read. There's also a great life skill. If you buy a house, if you need to sign a contract, you need to submit some employment materials, having these apps and being comfortable with them is very useful. We're going to start our week in reviews on Wednesday, so tomorrow at 5 p.m. Kaki, your graduate TA, will be hosting a optional review of what's happened in the past week, and it's an opportunity to come get additional exposure. This will be recorded and posted if you can't make it. But if you can, it's a good opportunity to be on Zoom and interacting with questions about review going up to the quiz. So let's talk about the quiz. The first quiz is on Thursday. It will open on Gradescope at 3:30 for section 1, at 5 for section 2, and for international students who opted in to the GMT +8 offering, which is 13 hours difference from Eastern time. I'll be sending out an email with more information on how you'll take the quiz. There's a separate Gradescope for that as well. The standard amount of time will be available to you, 75 minutes. The actual quiz will be designed for 60 minutes. And the reason for that is because I want to be sure that you're not up against the clock trying to submit your scanned assignment. So you're going to get some practice scanning your work today, and you'll want to start doing that at the 60-minute mark on the quiz to be sure that you've got enough time. If you have ARS accommodations and those were sent through the system, they'll be applied, so you don't have to stress about that. This will be synchronous during the official course time. We will have office hours if you have conceptual questions like about the wording of something, but our TAs and I can't help you with, we can't hint you along at an answer, but if there's like a word that we need to define or something that feels off, we'll have office hours going. And you don't need to join Zoom. There's no collaboration on quizzes, and we do take this very seriously. Gradescope can produce reports of suspected collaboration based on a number of factors that is highly accurate. So I would encourage you to avoid any temptation to collaborate on these assignments, and we're going on honor code here. You can use your notes, you can use VS Code, you can use course materials. The best way to gain practice is think through what we're doing today. Looking back over some of the responses to the lessons that you've completed already, and if you want additional exposure, coming to the Khaki's week in review. All right, so with that, let's jump into a warm-up question. And this was the first question, or this was the second question that was asked in Poll Everywhere. And it doesn't have consensus results. So let me just pull up the results here of, Poll Everywhere is once again being a little bit slow. I think Poll Everywhere struggles when I'm streaming, but I can see that there's, some 60% said 6.0, and then there are a variety of other options. So let's try working through this, right? When you see a problem like this, your old friend PEMDAS is coming back into play, right? Please excuse my dear Aunt Sally is how I learned orders of operations. And so we know that P is parentheses, exponents, multiplication, division, addition, subtraction. But there's some caveat here. And this is something that because it's been so long since I think all of us have thought about this, this was actually one of the most missed questions on a recent lesson. And all of the question comes to, which of these operations comes first, division or multiplication? Well, by this ordering, multiplication should come before division, right? But the key thing to remember is that multiplication and division and addition and subtraction are actually at the same level of precedence. So these are equal. And because they're equal in precedence, that means that we evaluate them from left to right. So if you have multiplication and division, such as we have here, it's as if we have implicit parentheses to carry out this operation first and this operation second, right? So if we work through this, 4 over 2 is 2. And that leaves us with 2 multiplied by 2. And then we have 2 plus this, right? And you all are Carolina students who have taken calculus. So this is, I don't want to insult you here, but just to finish this out, 2 plus 4, right? And ultimately 6. Now there is one more piece of nuance here that we've got to be careful with. This isn't actually fully correct, even though this made sense, right? I skipped over an important step. One of the things that we need to be careful with when we're thinking about expressions in terms of a programming language like Python is that every part of an expression has a specific type associated with it. So each operator has a type. And if I go back up to this first step here, there's something I didn't do, right? So all of these initial values are integer literals, right? So the type of 2 is int, the type of 4 is int, the type of 2 is int, the type of 2 is int. Right? These are all integers. But division, the division operator is an interesting one. It actually converts whatever the result is to a floating point value. In other words, it converts it to a number with a decimal. So 4 divided by 2, that sub-expression would actually evaluate to 2.0, right? So we would have a float value here, right? And the float is referring to, this idea of this decimal sort of floating around for reasons that are a little bit beyond our concern. But whenever you read the word float in a Python program or in other languages, know that we're talking about a number that has, a decimal and a fractional component associated with it. There's also, this integer and this integer too, right? So there's another int, right? And now we're in this world where we've got mixed types here. So we're multiplying a floating point value by an integer. Well, what happens? Well, by default, and this is common to many other languages as well, this integer is going to be converted automatically for you to a floating point because it is likely that you want some more precision than an integer would give, right? If this were an expression that didn't evaluate to, an even 2, right? If this were 4 divided by 3 or something, you wouldn't want an integer by default. And so this would actually result in 4.0, which would be a float, and 2 added to it, which is an int, right? So 2 plus 4, just like with multiplication, addition, any of your numerical operators, when they are operating between both a floating point value and an integer value, are going to result in a floating point value, all right? And so 6.0 was the expected correct result here. There is some question as to whether or not poll everywhere was graded for correctness, and it's not. It's for participation. I want you to engage with this content and interact with it. The warm-up questions specifically are what we're looking for engagement. The questions that come later are more optional. But the assignments on GradeScope, the lessons are graded for correctness. However, we will drop your lowest 3 at the end of the semester. So don't stress about that. I expect everyone's going to have approximately 100% as long as you're submitting everything on the lessons. All right, so let me look and see if there are any questions that have come in. All right. So the top question right now is, what should we study for regarding this quiz? I'll post a list of subjects and email that out over Sakai so that you have a better list to work off of. But roughly, it's some of the most recent lessons and what we're looking at today. So the data types, floating point, integer, string, operators and expressions. Like a problem like this is something you could expect to need to be able to work through on a quiz. And we'll look at variables, and they'll be important as well as the things that we see today. I'll talk a little bit more about them when we get there. Another question that I'll just get through real quickly is VS Code prompts. Would you like to make Pylance your default language for Python? Yeah, you can say yes to that. What Pylance is, it's checking over your back. And it's trying to make sure that if you are working with these types, like you're trying to do something with an integer that you really can't do with an integer, you really needed to have a string in order to do that, it'll help you. And it'll tell you like, hey, it looks like this doesn't quite add up. And knowing that as soon as it happens can help you avoid errors that are otherwise pretty confusing when you're just getting started with programming. There will not be papers every week. We're anticipating 3, maybe 4 papers this semester. So with 15 weeks, that's one every 4 to 5 weeks. looks like I think I just answered it. The answer is 6.0, but there's a question of why is it not 6.0 with quotes? And let me try and tackle that real quickly in another slide. So let me go one more over. So what's the difference between 6.0 versus quotes 6.0, right? The key difference is this 6.0, its type is a floating point, right? So it's a numerical type. And you can do the things that you would expect to be able to do with numbers with a value that's 6.0. For example, we could multiply this by 2 and get 12.0 out of it. When you put quotes around a value, that's what forms a string literal, right? And in Python, we shorten the word string to just str for its type, right? And a string is used for textual data, right? So textual data are things like your name, you could imagine certain types of numbers being closer to string data than textual data, such as your social security number. You're typically not doing arithmetic with your social security number, and it has dashes in it, and so there's like numerical data mixed in with, but it's really more textual data. Whereas like when you're thinking about the balance in your bank account or the points that you scored on a problem set or something like that, you tend to think of those things as numbers that you want to be able to do arithmetic with. We're going to look at some of the things that you can actually do with strings differently than the numbers in the next practice problem. So it's going to be a challenge because it's going to look at some things that you haven't talked about yet, or that we haven't talked about yet. I would encourage, if this is still fuzzy, the difference between string and float, the assigned reading on the data types is a good place to go back to and check your understanding, as well as coming and talking with us one-on-one. All right. So there's another great question, and then this is the last one I'm going to take before moving on to the next challenge problem on Poll Everywhere. But if you were to use double forward slashes, so what is the difference between say 4 divided by 2 and 4 double divided by 2? So this is a nuanced distinction, but it is an important one. 4 divided by 2 is going to result in 2.0, which is a floating point value, right? What if you really wanted to have an integer division take place here? Well, you would get just the number 2, and it would be int if you use it's sort of a special case of the division operator, which is integer division, right? Now, this is where you need to be kind of careful. If you were to have something like 5 integer division divided by 2 versus 5 floating point, well, what's the difference here? Well, in floating point, this you would expect to get something like 2.5 here, right? Well, what about 5 divided by 2? Well, when you're doing integer division, the fractional part or the remainder gets truncated or thrown out. So this would just be 2, right? And you can think of this as, if you have 5 people and you're trying to form teams of 2, how many complete teams can you form? And that would be 2. Integer division is something you probably haven't spent much time thinking about or practicing in quite some time, but it does come up quite frequently in computer science. All right. So the next question that I want to throw it to is a challenge question. And this is going to have a response on Poll Everywhere that I'll open up now. So that this should now be active if you're synchronous. If you're asynchronous, don't worry about trying to respond and just write it down, your response on paper. I want to give you a few minutes to think about this, and we'll come back and discuss what the evaluation of this is. It's going to be hopefully maybe kind of surprising based on what we've discussed so far. All right, I'm seeing over 200 responses. So that means over half of you have responded, and those of you who haven't, hopefully are very close to it. I don't want to rush you, but since this is an idea that we haven't actually talked about yet, there's no expectation of correctness here. Turns out over half of you were able to use some intuition to get to the right answer. So let's think through this. The first thing we need to talk about is types, right? So types are important, and it's worth thinking about the types of, every expression that you write in a program or a programming language. And so we know that each of these types in the parentheses is a string, right? So string, string, string. And then this is an integer, right? So we know it's an integer because there's no quotes around it. There's no decimal place or zero. So this is just an integer value. Well, what does it mean to use the plus operator between two strings? Well, this is a concept that's called string concatenation. It's got a really fancy name, so I think it's worth mentioning this. So string concatenation. And this name is inspired by chemistry. In chemistry, you can catenate bonds between many carbon elements, and you're sort of stringing them together. You're creating a chain of atoms when you concatenate them in chemistry. Same idea with concatenating strings in programming. So the idea is, in the readings, you learned that each string is actually, a sequence of characters. These strings happen to be sequences of single characters. So it's hard to think of this as a sequence, but there is one character in each of these sequences. And so when we concatenate them, what we're saying is, because this is going to evaluate left to right, same level of precedence, this would first evaluate to the string 1, 1, and then concatenates with 0, and this is the first evaluation of this, right? And so now look, what happened was this concatenation operation, which looks like the addition symbol. It is the addition symbol, but when you're working with two strings, it has a different meaning than when you're working with two numbers. And the meaning when you're working with two strings is take the values of these two strings, bring them together such that, and you'll hear this terminology used frequently as well, the left-hand side of the operation is followed by the right-hand side of the operation, right? So the operator is the plus symbol. We're concatenating the left-hand side to come before the right-hand side. And so that's what leads to, 1 followed by 1 in this new string that it produces. So this is a brand new string. All right, well, let's do the same thing with this concatenation operation. And here, we're going to see that this becomes the string 110, and that would then be multiplied by 2, whatever that means. Well, we'll get there in just a moment. But just to reiterate, concatenation operation takes the left-hand side, and it's then followed by the right-hand side, and we've formed a new string. So this is now the string whose first character is the digit 1, the second character is the digit 1, and the third character is the digit 0. So now we have this multiplication operator to worry about. And Python does something really cool with this operator that you all figured out. It says repeat the same string some number of times over. So the ultimate result of this is going to be 110, 110, right? So a string where the characters 110, 110 is followed after another, right? And you can play around with this in the REPL. Right, so if I open up my REPL really quickly, and I open up my terminal, and I start my Python REPL, right? So I've got my Python bound to the word Python. I think most of you were able to successfully do that in the setup. And so in VS Code, I've just opened my terminal and started a Python interactive programming session. And so if I have a string like, ha, and I use the string repetition operator, which when you're working with strings takes a string on the left-hand side and a integer on the right-hand side, and say, multiply that by 10, we get the string ha 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 repeated after that. And you can do some fun stuff with that, right? And we can do things like LO and L multiplied by 100 for that really great text that you were sent with the Bernie meme, right? And you kind of get the sense that these operators, which mean one thing when we use them with numbers and data types that are integers or floating points, can mean another thing when we're dealing with string values. And as we learn other data types as we move through this course, you'll see that they have other meanings as well. All right. I'm going to come back to questions real quick. So I'll talk more about the format of the quiz. Actually, I can address the format of the quiz question now. It'll be a combination of short answer, multiple choice, and diagrams. It won't be one thing. It'll be of a very reasonable length to finish in the time allotted. Tutoring sessions will not be recorded. And this is for everyone in the course's privacy. They're really not, tutoring doesn't come with an agenda or a fixed format. It's really a conversation between who shows up and what it is that folks want to talk about. And so this is a dialogue back and forth on Zoom with potentially one-on-one between TA and student, or if there's multiple of you and people want to talk about the same subjects, it can be a small group discussion. Okay, another good question is there a difference between single quotes and double quotes? And let me just talk about that really quickly. So the difference between one and one is subtle. And it turns out there isn't really a difference for our purposes. You're going to see us always prefer to use double quotes. And the reason for this is if you go off and you write Java programs or other languages, double quotes tend to be more common as the preferred way of quoting your strings. Single quotes are commonly seen in Python, and you'll notice that even in the REPL, that's what gets produced here. So there's no difference. And if I were to just use a literal like hello, we see that Python just gives me back the string hello with single quotes. Hello with single quotes is the same thing. Both of these are strings. They have the same meaning. The reason for one versus the other is something that we probably won't have to worry about in this course very deeply, but what if you wanted to have a double quote quotation in your string? So you wanted a string that's like, she said, what? Right? Well, you've got this problem where the programming language doesn't know, it's going to think that this is the end of your string, right? Because we use these to surround our string values. And so there's two ways of getting around this, and I'll show you only one of them, the one that's the simpler way. The simpler way is to use, if you find yourself needing to use double quotes in one of your strings, that's when you would want to use single quotes to surround it. That's a little bit beyond our concern. This isn't something we would quiz you on or anything like that, but that's why both of them exist. The same exists vice versa, so that you can use single quotes within double quotes more easily. All right. Okay, that's a good question. So the next question, and before we go on to one more set or we go on to an interactive exercise, is what happens if you do 110 multiplied by the string 2. And I would encourage you to try out these ideas. You're not going to hurt anything. Notice that we have a type error. This operator, the repeats operator, when you're using it with a string, it doesn't know what to do with this, right? Because it makes sense if you multiply a string by a number, we can all appreciate that means just repeat that string this many times and create a new string. However, what does it mean to multiply string by string? I don't know. And so no one's defined this. It doesn't exist in this language. And if you try to do this, you'll get a type error. And this is one of the reasons why types are important, because they tell you what you can do with your data. And that's actually probably one of the most fundamental concepts to appreciate in this first segment of the course and carry forward with us is types are very important in your programs because they tell you what you can do with the data that you have available to you. There are things that you can do with strings that you can't do with numbers. And as we start to invent our own types, like if we wanted to model the idea of a cell or the idea of a grade, for some component of a course. When we invent our own types, we'll be responsible for defining, well, what can you do with that type of data? And so a key understanding with types is they tell you what you can do and what's valid in a program versus not. All right. I'll talk about diagrams when we're just about to get to diagrams. So what I want to do next is, and styluses as well, is a follow along. I'm going to turn it to you all to start a new file in your Visual Studio Code workspace. So open the File Explorer after opening the workspace, and you'll see your directories on the left-hand side. There's a lessons directory. You can go ahead and right-click, create a new file. I'm going to leave these instructions up here and give you a minute to catch up with this because there is some typing here. But I just want to talk through this first real quick. We'll name this file input.py because we're going to look at how do we actually ask the person using our program for some input. And it's a simple program that has a document string. It's a program to demonstrate user input and variables. This first line of code that you're going to add to the file, the document string, its purpose is to just describe what comes in the file. And there's ways that we can access this that we'll look at later in kind of neat ways. So this is just a description that we'll have in all of our exercises and projects in the course. And then there's two print statements that both use concatenation. So we're concatenating the string wow, comma, space, and there is a space here, and then the concatenation operator. And here we're seeing an idea that we'll talk about in more depth as soon as we're all able to be on the same page here. But we're asking for input. Who are you? So what's your name? And then we're concatenating the string you rock, right? So this is what we're going to see as a function call expression, and it will pause our program at that point, ask the user to enter their name effectively, or it will ask, who are you? And the user can enter their name. And as soon as you press enter after that, it will evaluate to the string that was entered. And similarly, on the next line, it'll ask you that question again. So this will be a kind of annoying little program, and it'll tell you to have a nice day. We're going to improve this program so that it doesn't ask you who you are twice in order to achieve this same goal in just a moment. Once you've got this code in your file, I would encourage you to try running it. So close any open terminals you may have. If you're following along with the previous example, I would press the trash can to quit out of that and open a new terminal. And then we'll get used to running a command like this, where Python, we're running the module that's in our lessons directory, and we named this file input, so .input. And I'll have a poll to check in once you've reached this point. If for some reason today's example doesn't work for you, don't stress. Come by office hours tomorrow. You'll still be able to follow along with the rest of lecture, totally fine. The first few weeks of COMP110, there's lots of these little technical hurdles to get over, but we'll all get on the same page here very quickly, and you won't be behind. All right, so I'm gonna give you a minute for this and open up that poll. one more minute on this. And if you're having technical difficulties, don't stress. It's totally fine to just follow along for now. All right. So I'm going to open up this example in my window. And so in my lessons directory, I right-clicked new file, set up input.py as my file. Whenever we're working through one of these interactive examples, one of the nice things about VS Code is it just below the tab that you're currently working on, it does tell you the directories that your file is in. So if you're wondering which file or directory I'm currently working on, you can see that it's in lessons and input.py. If for some reason you see any errors about test discovery, you can ignore those for now. We'll talk about testing later on in the semester. All right, so what are these 3 quotes? Well, this is a special kind of string that is for our documentation purposes. And there are programs that can take your Python code and turn them into web pages and documentation for other people to tell them how to use it. And if we did that for this particular file, what we write here would show up at the very top of that generated web page. When you're reading documentation on the Python programming language and reading about some of the functions that it has and things like that later in the semester, those pages were generated in this exact same way. So next we see 2 print statements, and I briefly talked about this, but let me close out my my terminals that I had open. So the trash can is going to be your friend when you're starting up and running a new example. And I'm going to say Python. If you need to run Python 3, same thing, it's totally fine. But hopefully once everybody's set up, you can run Python directly. And for some people, just the shorthand py can work. The -m is saying, I want to run this particular Python module as a module. If we didn't have it, it would the nuance is like kind of beyond our concerns as to what would be different at this point. But this is a nicer way of running our programs that will help us right now and in the future. And then lessons.input, right? And so notice that this very first string doesn't print out, right? It has no effect on the output. That's just a string that's there for documentation purposes so that when you come back to this file, you know what it's all about. And then notice that wow wasn't the first thing that was printed, right? The first thing that was printed was the string, who are you? And notice that this is an example of order of operations, right? The same way that our parentheses need to, anything inside of like deeply nested parentheses needs to evaluate first. Same idea when we see, these function calls. So print has some parentheses, and before we worry about those, we need to figure out, well, what is this expression? This is a string concatenation expression. What does it evaluate to? Well, before we can worry about that, we need to figure out, well, what does this function call evaluate to? And this is what's asking us to enter a name. So if I enter, Chris, as soon as I enter Chris and press enter, this function call evaluated to the string that I wrote into my terminal, right? And then this became wow concatenated with the string Chris concatenated with you rock, and we print that out. And so notice that's what causes wow, Chris, you rock. Thank you, program. You're so nice. Same idea here. We're once again waiting to respond to who are you. And as soon as this is given an input, and I'll say my name again, Chris, have a great day is printed out. This input function call is one that is waiting for us to take some action, and based on what we provide, it is going to evaluate to that string before the program continues on. All right, So the next thing we're going to do is actually improve this program a little bit. It's pretty frustrating that we have to enter our name twice. We would really like to only have to enter a name once and then be able to print out multiple messages having sort of kept track of the first name that was entered. And that's one of the reasons why we might want to use a variable to keep track of some value so that we can use it at multiple different points in our program later on. Let's try defining one. So I'm going to close this terminal out for now. And we're going to look at some of the details of defining variables in just a moment. I've got some more slides on that, but let's just get an intuitive sense first. So we can say that there's a variable that's going to be named name, whose type is going to be string. So we're declaring, hey, from this point forward, the word name is going to refer to a value whose type is string, and we need to give it some initial value. So we're going to assign to it, and I'm actually going to cut. So select that text and Control X or Command X on Mac and replace it with this variable name. All right. So I'm going to modify my program in two ways and give you a chance to do this as well. So that second time that we called the input function, I'm replacing that with name too. All right. So let me try marking this up just before moving on and giving you a demo and convincing you that this actually works. Let's talk about what's happening. All right. So what we did here is we declared a variable. And its name is name, right? And so from now on, if we use the name, it's going to refer to whatever value that we bound to that variable. So what did we bind to that variable? Well, we're going to ask the user, who are you? And whatever string they give us is going to be assigned or bound to the variable whose name is name in our program. So when we get to the second line and we concatenate name, it's going to refer to whatever string the user had previously given us. Same with this second line, all right? So when I try and run this program, we're going to be asked for our name once, because whenever our programs run, they start at the top of the file and they work their way down line by line. And then we'll see that as soon as we enter the name, we'll get both of those messages printed out immediately. And it'll be a much nicer and much improved program, right? So let's try this out. So I'm going to write python-m and lessons.input. Who are you, Chris? And wow, Chris, you rock. Chris, have a great day. So notice that both of those values were printed out and we didn't have to ask the user to enter their name twice. This is possible because we could use some memory to keep track of that name. And that's the purpose of a variable. It allows us to come up with something that we want to store and use at many different points later in our program. All right, so let me take a look at questions that have come up. I'll talk about modulo a little bit later. But actually, I'll address the modulo question head on really quickly. So when you take the remainder and you don't have enough, this first number is smaller than the second. It's like, how many teams can you form if you, how many teams of 5 can you form if you only have 3 people? And the answer is 0 teams, but you have 3 people left over. And so the remainder would be 3. This is incredibly cute. Yes, we're going to make like hella cute programs this semester. I'm excited for the abundance of cuteness that will exist in our code. Why do we use Python versus Bash? We'll get some more experience with this as we move forward. In the previous lesson, I talked a little bit about what a shell is, right? And so the shell is what sort of we interact with as someone using our operating system to start up programs and to control what's going on in our computer. Bash is a shell. And if you're on Mac, you might see ZHS, same thing. Bash and ZHS are both shells. That SH is short for shell. So that's what allows us to start and stop programs. Python is a program, and it just so happens to be a special kind of program, an interpreter. And that interpreter is a program that takes, when we run Python, when we start up Python in the program and tell it, hey, this is what I want you to do, Python, it takes our code and it interprets it. And so that's what causes a process to run our programs. Great. So is there a difference between defining variables with this type string versus not? I'll talk a little bit more about that when we get specifically to some of the details of defining and declaring and working with variables. What I want to do next is actually diagram what's going on in memory here. And then I'll come back and look at some of these other questions in just a moment. These are great questions, by the way. All right. So next we're going to try diagramming. And so I'd encourage you to have out a piece of paper, or if you're taking notes on a tablet, that's fine too. We're going to ask you, it's not effective to use a diagramming application that produces like prefixed shapes with connectors and things like that, like Notability, or there's some that you can produce, very professional, technical grade diagrams. We're going to ask you to handwrite these, whether you're using a tablet or paper, it's fine, but you should have, a stylus to do this, or a pen. And in fact, I would probably encourage, if you're torn between the two, pen and paper is encouraged because it's so much easier to access. All right. So what we're going to look at first is, and this actually is not the diagram that we're going to submit to Gradescope. I'll talk about that one in just a moment. What happens if we have a little program like this? I'm actually going to just do this in VS Code directly rather than in PowerPoint. So here we've got 3 variables being declared: a name, an adjective, and a body part. And we are ultimately producing a pirate name. Right? So if, let me give you an example of what happens when I run this. Right? So if you don't need to copy this program down. We're just going to practice diagramming this, right? So there's no sense, there's no expectation that you write any of this code, but just to show you what happens as from the user side, and then we'll take a look at what happens in memory. If I were to run this program, it asks me for my name, Chris, an adjective, long, and beard, right? My pirate name is Captain Longbeard Chris. All right, so it's another silly little program, but this will give us another example of how variables work and gives us some context for thinking about diagramming. So I'm going to make this just a little bit smaller, and I want you to sort of follow along with me as we talk through our very first, what we call a memory or environment diagram. Oops, didn't mean to click out of that. All right, so let me clear this away. All right. So as I mentioned in the previous video, we've got a certain area of our program that's going to be called the stack. And for right now, we don't really know what its purpose is. As soon as we get to functions and defining our own functions, we'll learn this area has much more significance and more nuance. But for now, on the stack, we're only really going to be focused on what we call frame. So we're going to have a globals frame. Right? And a frame is just going to be sort of a box where our variables are the names of our variables will exist and be defined, and then they'll be bound to some value, whatever we assign to them. Right? I talked about in the previous video that there's also the built-ins, some of these functions that are just built into our language. We're not going to be diagramming those because they would exist on every diagram and they would be kind of redundant. We're only going to be focused on the code that exists in whatever program we're trying to follow along with. You'll also see the word trace, so tracing a diagram. Tracing is the process of stepping through a program piece by piece in order to understand what it's doing. So what we're about to do is trace through this program and produce a diagram. When this first line of code is evaluated, nothing happens that's visible or meaningful in memory. Again, this is just a comment that exists for our understanding as someone using the program, or someone reading and writing the code of the program. On line 3, when the Python interpreter reaches this line, we see a variable declaration statement. And we'll look at the details of what this actually means in just a moment. But we're defining a name, just like we did before, giving it a type, string, and then assigning some value to it. And this value is what the user gives us. So here on my diagram, I would say, okay, let's set up some space for the name variable. And the name variable is initially going to be assigned. Let's imagine that I told you that the first input was Chris, and you can use your name if you'd prefer. All right. And this is what happens when we declare a variable and assign it some value. So if I had entered Chris, we would have had the string Chris bound to the variable name. So later when we reference name, that will mean Chris, the string. Same thing with adjectives. So I'm going to go ahead and enter an entry here for adjective. And my adjective was long and then beard. You can choose whatever adjective and body part you'd like. The next, you'll notice that we have a variable that has two words as a part of it, body and part. The names that we assign our variables have some rules, and they kind of have to be one contiguous string of characters. And here, when we have multiple words, the convention in Python is to put an underscore between them. Right? So body part is the next variable name, so body underscore part. And I entered beard. You can choose whatever you'd like to be your pirate name, right? All right. So these three lines evaluated, one after the other, right? The computer's just following along line by line by line. And then it reaches line 7. Now this is what we call an assignment statement. It's similar to the previous statements, but one of the things that you've got to be comfortable with variables is that we can actually change what a variable's meaning, what it's bound to as the program's running. This is really useful if you had a variable that kept track of, say, the points of one player in a video game. You want those points to be able to increase and keep track of that. Well, here what we're doing is we're going to build up we're going to reassign the string, reassign a string to our variable name. And what is this going to be built from? Well, it's going to be built from concatenation. So name is no longer going to be Chris, and I'm just going to cross that out. It's now going to be the string that is, Captain, and then a space concatenated with, and here we reach a variable reference, right? So we need to look up, well, what is adjective? So we look in our current frame on the stack, and adjective, we gave it long. If you gave it a different adjective, a different string here, you would enter that next. But when we reference a variable in our program, after it has some meaning bound to it, when we use it, it gets substituted with that meaning. So in this case, the adjective would be long. And then we're concatenating a space. So if we didn't concatenate a space, there would be no space between the strings that we're concatenating, and it would just be long beard with no space between them. So there's another space. And then the body part was beard, same idea. We would look up what does the name body part, what is it bound to? And as this program was running, I entered beard. Similarly, space, and then name, I entered my name, Chris, right? And so this is a very long string. Typically when we do diagrams, we wouldn't ask you to diagram a really long string like this out. But just to give you a sense, now when we use the name later in our program, so your pirate name is, and then we concatenate name, it's no longer going to mean Chris or be bound to Chris. It's going to be bound to Captain Longbeard Chris. One other thing that's an important thing to know about variables is we always do what's on the right-hand side. So remember the right-hand side of our assignment operator, so this equal symbol. We're going to figure this out first, and then that's going to be assigned to whatever variable is on the left-hand side. And that's not something that you can swap up or switch around. All right, so when we finally print out your name is, and then concatenated with name, the output, which would be something that we would keep track of on our diagram somewhere else. So we'd have an output column. The output would be your pirate name is, and then Captain Longbeard Chris, right? So we do keep track of our outputs when we are diagramming in this way. So there's some concern, Beard Chris, right? There's some concern over whether your bash shell looks the same as mine. Mine's just that dollar symbol. Don't worry about that. If yours looks different, that's totally expected, actually. I simplified it down to just a dollar symbol because otherwise it probably would include my name and other stuff that would be very specific to me. So as long as you're in bash or ZHS in your terminal, that you should be fine. All right. Another question when it comes to actually running these programs is it okay to just hit the green play button? I'm going to encourage you to use your terminal to start your program. Early in the semester, it doesn't really make a difference, but as soon as we start having programs with multiple files, hitting that play button won't work. And if you're in the habit of just using the terminal, it's a good skill to build. That's how most professional programmers would interact with their programs. Then you won't run into that problem later on. All right. Great. Is there a reason I skipped lines in this example? No, mostly just for legibility. There's no difference if these lines were all one after the other. I sometimes like to cluster related lines. So these first three were all about gathering input from the user, setting up our variables. The next line was showing how we can reassign a value to a variable and change its value. And the last was just printing out that output. So there's one other diagram that I would like you all to try working through. And I want to give you 5 minutes on your own to try working through this, and then we'll work through it together. This diagram is actually one that you'll get practice submitting on Gradescope. So there will be a Gradescope entry for you to use the scanning application to scan this and upload it, or if you're doing it on an iPad, to export a PDF or PNG and upload that. But it should be handwritten. And I want to give you a few minutes to try on your own diagramming this, and then we'll come back and work through this together. As you're working on this, just a couple of quick notes. First, you'll notice that I'm using this int function, which we mentioned in a previous reading, and that's going to convert the input that we give, which is hopefully a number, to an integer value that we can then assign to age, which will hold an integer rather than a string, so that when we get to line 5, you'll be able to do some of that arithmetic. So that's what's going on there. And similarly, if we want to concatenate a number back into a string, we need to convert it to a string. So this would just convert whatever is in the age and 2041 variable back into a string so that you could concatenate it. All right, I know many of you are still working on this, but so that we can get through this with the 10 minutes left in lecture, I want to go ahead and start talking through it, and hopefully it aligns with however far you were able to make it. A question that came up in Polev was, should you be diagramming in the same way? And sorry for not making that explicit, but yes, when I get to drawing out the stack and the globals frame, this is what you should also be trying to reproduce when you're tracing through one of these diagrams on your own. So I'm gonna make this a little bit smaller so that I can have a little bit of space to write here. And let me clear out what we were doing previously. So when this program begins, we're gonna have a stack set up, and I'm just gonna put mine beside of the example here. And our stack is gonna have this globals frame, right? So globals. And this global frame is where, when we declare these variables, they're going to exist. All right. So the first variable is age, and hopefully you used as the input whatever age yours is. And I'm going to give away how ancient I am here in just a moment. But age is going to be a variable, and it's an integer. So this declaration is telling us the variable age is going to hold an integer value. Well, what value is it going to hold? It's going to ask the user, how old are you? So when I enter 35, that's going to be a string, right? And you can enter whatever age that you are. That would be a string value that we get back because we typed it in at our terminal. And in order for us to use that input as a number, we have to convert it to a number. So we convert that string to a number using this int function, right? So the result of this expression, if I entered 35 as my input, would be the value 35, that's an integer. Same idea for the next line. There would be another variable that gets declared named year, and its value would be 2021 if we entered that, all right? This next line is an interesting variable declaration, and what we'll see is called an initialization step, where we've got some arithmetic that we need to perform. So I'm going to reproduce this line here just so you have a sense of what we're talking through. So you wouldn't need to rewrite a line like this. This is just me, scratch working this out for you all. So the name of this variable is going to be age in 2041. It's also going to be an integer, and it's going to be assigned the result of, I'm going to loop around here, 2041, the number, minus the current year, or whatever year we entered, plus age. All right. So what happens when this particular line evaluates? We're on line 5 here. Well, first we need to figure out, what does this expression evaluate to? So it will be 2041, and I'm just going to write down on the next line what this would evaluate to, 2041 minus, and year. So what is the variable year bound to? Well, it depends on what the user input, but let's pretend we input 2021, so it would be 2021, and then plus, and then whatever the age that was entered, so 35, right, in my case. And you can use your age and whatever year you want in your example. So now we need to figure out, well, what does this expression evaluate to? We just substituted the values bound to year and age. Well, this would be 20, right? So we have to do the left to right for subtraction and addition, and 20 plus 35. And for me, that would be a pretty horrifying 55, right? So all of this expression right here would evaluate to 55, and then would be assigned to the variable age in 2041, right? So none of that you needed to actually write down. This computation you could do, scratch to the side. What would ultimately happen in memory is we would have another variable, age in 2041, and for me, based on my inputs before, that would be assigned 55, right? But this expression needed to evaluate, and then it was assigned to the variable. And so now when we reference that later, and on line 6, we see that that variable name is being used, right? So now we're trying to print, well, what is the string representation of that? It would be the string 55 for me, and that would be concatenated with, in 2041, I'll be 55, or you'll be 55. So the output that we would expect in this diagram tracing, and you would also include on your diagrams whatever the printed output is. What we would see show up is in 2041, you'll be, and then 55, right? So that got concatenated. In output, there's no expectation that you have to use quotes. When it gets sent to your screen, it's going to be textual data. Either way is totally fine. In the memory diagram, in the stack, and later when we learn about another space, there is significance in whether, like, these are all integer values. If we had quotes around them, they would be string values. Output is effectively always going to be a string, right? Okay. And so that's, oops, I shouldn't have deleted that. So in 2041. So this is our first line of output. And then we reach these next set of lines. So line 8 is a really interesting, and coming from the world of math, feels very backwards variable assignment statement. So let's break this down. It turns out this is completely valid Python and completely valid programming, a completely valid line of code. So remember, when we see an assignment statement, we're trying to update the value of a variable. The new value is going to be whatever's on the right-hand side of our equal symbol, and the variable that we're assigning that value to, or rebinding or changing its value, is going to be on the left-hand side. So we're saying here, what is the current age? So the current age is 35. Notice that nothing that we did previously changed the variable age. We're about to, though. So age is 35. So this would be 35 plus 1. And that's being assigned to the variable age, right? So 35 plus 1, we know that that's 36. So age in memory is going to update to be, I'm just going to cross that out, 36, right? So what we did on line 8 is we updated age by 1. This is just like if you had a points variable in a game and you wanted to give the player another point. This is how you would increase a variable's value so that it had a higher value. We could also decrease a player's value, things like that. We could subtract 1 from age, all right? Same idea is happening with year, right? So we take the current year. So the current year is 2021, and we add 1 to it. So it'd be 2022, right? And that is going to be stored back in the year variable. So in year, it's no longer going to be 2021. You know, it's going to be 2022. Right? And so those two lines effectively changed both the age variable and the year variable, the values that they're bound to in your diagram, right? So when we go and print out, well, what is, the value of year and the value of age? Well, when we get to line 10, we look in our diagram, we see, okay, year is 2022 and age for me was 36. So the second line of output that would be printed is in 2022, you'll be 36, right? After that line, there was no more code. This is a special, I added this as an instruction, and this is what we call a code comment. We'll talk more about code comments and the difference between, that first line of the program later. But anything that you put on a line following a hash symbol is going to be ignored by the programming language and is just for humans to take notes, right? So that's actually a good reason to mention it. If you did want to take some notes in programs that we're working on, you can add a hash symbol and say, these are notes for you as the programmer. Right? All right. So this would be our, our environment diagram or memory diagram. And this is what you'll want to submit to Gradescope. Typically, you'll see me have the stack more to the left because we're going to have another area in our diagrams called the heap later on in the course. But the arrangement of these things physically doesn't really matter. But for a given, typically you would have the stack and then down below it or off to the side somewhere, the output. I was just trying to fit it all on the screen to make this work. And maybe what we can do is actually provide an example of what we would expect like the practice diagram to look like. But it's really mostly about what are in your frames on your stack, and we'll learn some other components as well as what was the generated output. If we wanted to convince ourselves that this is actually what would happen when I run this program, let me hide my diagram really quickly and say Python M lessons.diagram submit. And 35 was my age. The year is 2021. And you'll notice that we got that exact same output. All right, so we've reached time. And I know that everyone has busy schedules, so if you need to hop off right now, that's totally fine. I'll spend just a couple minutes looking at questions. And then the last piece of content that will go up by tomorrow is some more discussion around some of the specifics of these variable declarations. And as soon as that goes up and the list of topics for the quiz, I'll email everybody on Sakai. All right, so let me just move through the top questions. And again, if you need to hop off because we're at the end of lecture, that's totally fine. Is there a difference between defining variables explicitly, stating the type, so like we're doing here, versus not? So this question is, let me make this a little bit bigger since I'm done diagramming, is there a difference between this and this? And the answer is sort of subtle. You'll notice that with Pylance installed, if you hover over your variable, it tells you what type it is. So age is an integer. So when you see that colon, you can read that as is a. So age is an integer or is declared as an integer. And so our programming language is inferring that, well, based on how we initialized it or based on what we assigned to this variable, it must be an integer. It can't be anything else, right? As we're just getting started this semester, and there are some places where this will be absolutely required, but as you're just getting started, I would encourage you to try and get in the habit of declaring these variables with specific types. And the reason for this is it can actually help you, it helps you avoid accidental issues. So if I had written this line of code, notice that I get these red underlines and I've got an error. It tells me that, hey, the error is actually this part down here, an expression of type string. So we've learned about expressions, and this is a function call. Input is a function that returns a string. An expression of type string cannot be assigned to something that's declared of type integer. And that's like, oh, if you see that, oh, I must need to turn this string, which is the result of input and what I typed in, into an integer in order for me to store it in age. And that would work out. But if I didn't do that, what I'm going to see is, well, this line would work, but now I'm going to have these other weird errors where, age in this case is a string. It's inferred to be a string. And I didn't actually want that. And you can avoid all sorts of classes of problems like this by being explicit about what you expect to store in a variable. And this will help you avoid errors that are really frustrating and when you're just getting started, hard to understand. And again, the fix here is, well, input gives us back a string, so I need to turn this into an integer. All right. There's a good question about on a diagram. Let me make this small again. Do you need to cross out values or can you erase them and replace them? It's totally up to your preference. You'll see me later in the course probably lean on erasing them and replacing them rather than crossing them out because it does take up more space. But if it helps you to understand that, oh, this value changed and to keep track of that, and when you've got a little bit more space on paper than I do on my screen, I think there can be some value in seeing that phenomenon as well and understanding that, oh, it didn't start out this way, it changed this way. And we'll see variables that might change 3 or 4 or 5 or more times in a given program. All right. So what you should be writing down and uploading to Gradescope is effectively something that looks a lot like this. So have a stack section and have an output section, and whatever you're pretending to input, you would write into your age and update it accordingly. On the quiz, I would actually tell you, here's what you should input the first time you're asked for input, the second time you're asked for input if we wind up using this input function. Does a diagram have to be in specific order? Yes, so the output is going to be in a specific order. It's important to recognize and to, when you're thinking through these programs, to know that the computer, the best way to think about what the computer is doing, let me see how I can illustrate this, is to imagine that at any given time, it's only looking at like one small piece of code. So when your program first starts, it's going to look at this line. It's going to say, oh, that's a doc string. I nothing really for me to do there. It's going to look at this line. It's going to say, oh, that's a blank line. Nothing for me to do there. And it's going to move line by line from top to bottom. So whenever this program runs, this is always going to be your first line of printed output, right? This is always going to be your second line of printed output given this program. Later on, in fact, as soon as next week, we're going to see ways in which we can actually cause the computer to jump back to a certain place in our program, or to maybe go to one direction or another, take a fork in the road. So like we might want to ask a question of, do you want me to give you a fortune at the end of this program? And if the user responds yes, we want one action to happen, and no, we want some other action to happen. And in order to do that, we're going to have to learn a new type of construct that allows us to have our program move in one direction and jump to one place in our program versus another. But for now, based on what we know so far, we always start at the top and move line by line down to the bottom. You don't want to, the computer is not going to jump and say, oh, that looks like the more interesting part of my program. Let me evaluate that first. It's going to move top to bottom in order. That's a great question. If there's a red underline, it means that there's probably some kind of error. And the best way to understand what that error is to highlight over it, to leave your cursor over it for long enough for a little pop-up to occur. So here I accidentally deleted the letter T, and it tells me that input is not defined. And hopefully that lets me know that I maybe misspelled something. We saw another kind of error, which was if you use the wrong types, like here. And actually, let me give you a simpler example. If I try and multiply a string by a string, so this is a question that came up earlier. You'll see that the operator asterisk is not supported for, and here you're seeing a string literal 30 and a string literal 30. If you see like a literal and some quotes, it means a string. But more generally, if you have type issues, it'll say like this type can't carry out this operation or something along those lines. If you can't understand an error, please do stop by office hours and we're happy to try and talk you through what it means. For the diagrams that we did today, both the first practice, which was like the pirate name, and the submission, you don't need to reproduce these in VS Code. There's no expectation of that. These are just for diagramming practices. If you want to make additional programs like this, you're encouraged to just play around. Does it matter where the output is next to or under the globals box? No. Typically, I would not get in the practice of putting it right underneath globals, because we'll start to see that we use that space for other frames as we write more complex programs. So I would have it to the side, left side or right side, either way. So are we just writing down what the answer in the terminal would be? No, you're going to actually have both your memory, right? So you're never going to actually see this part of your program when you run it. You only see what's in the output. And you're going to keep track of both of those things in a diagram. For right now, it's going to feel kind of obvious, hopefully. Like you could probably do this without keeping track of these things on the stack. But as soon as we get to some more complex subjects later in the course, having a visual and being able to keep track of our variables is going to be really helpful. Do you need to back up lessons in Git? That's a great question. I would encourage getting in the habit of it. That way that you've got a record of what you've done. And if for some reason you deleted something, we could restore that. Another great question that I'll actually address. I mentioned that we're going to have some additional content that's sort of the drier take on what variables are and how to use them. But there's a great question that I think is best answered through an example. So what is the question? The first question, or the question is, I just changed my program. I just changed my program. And I put quotes around the word year. And does that matter? And it turns out it does. If you have quotes around a value, that means you're working with a string. If we just have, a plain old word like we're seeing here, or maybe some words that are separated by underscores like we're seeing, and we use it in this way, you'll notice that the highlighting is different. And that gives you a hint that you've got a different type of value in your program. This is referencing the variable year, whereas if we had, this, we would be referencing the string, literally the characters year, year, and it would be completely unrelated to the variable. So you do want to be careful with that. This is, we've seen literal string expressions, which are those values that are surrounded in quotes. And now we're seeing variable access or variable read expressions where this is the name of a variable. And so what that will evaluate to is whatever current value it's bound to. Is it wrong to create new stack variables with a new age and year variable? Good question. Within a frame on the stack, you're always going to have just one variable of a given name. Once we start to have more than one frame, which we'll see a few weeks from now, you might see the same variable name defined in multiple frames. But within a single frame, your variable is only going to be defined once and be bound to a single value at a given time. Right? So you wouldn't want to have two entries in globals for the same variable name. You only want to have one there, and it can only have one value. So the 3 quotation marks, I mentioned this a little bit earlier, but the meaning here is that we're just declaring something for documentation purposes. And so this tells us what this file is all about. We'll always put these at the top of our file, and we'll see them show up in a few other places as well. Do we need to put the inputs in quotes? Great question. So in this case, you'll notice that we were dealing with variables whose types were integers. And so I didn't have quotes in the diagram. I've already deleted the diagram. But if we were to go back in the video, we would see that there were not quotes for age because we converted it to an integer, which is a numeric type. In this example, when we asked for name and adjective, the previous diagram, we did have quotes because those variables were strings. So notice we just asked for input. We didn't convert it back to a number. Good question. On line 7, how can you redefine name and then call its definition on the same line of code? This is a great question. It has to do with the previous example. So the video that will be posted soon that gives a little bit more context on variables discusses this. But because the computer is only evaluating one part of this expression at any given time, it's first going to figure out what is the result of this part of the expression or this part of the statement. So it's going to ignore what's on the on the left-hand side and only going to focus on the right-hand side. And so if we think about, well, what is name bound to here? Well, it was whatever we previously gave it. Once it figures out what does this single value of the expression on the right-hand side boil down to, what is the single thing that it evaluates to? In this case, it's one big string. Then we're going to redefine what name means to be that. And so that order matters, right? We're first going to figure out what the right-hand side is, and then we're going to reassign it. Right? So always worry about what's on the right-hand side of one of these equal symbols, and then you're going to update what's on the left-hand side. All right. Let me just scroll through these last questions and see if there are any that are pertinent to what you need to know for Thursday. I talked about adding a type to a variable. You typically will want to do that in the early days. As we get into late semester, there are places where we'll be a little bit looser on that. But for now, the first time you declare a variable, so the first time we use the name, we said it was of type string. And then later, we know that it's of type string because we declared it to be that way. Is the code that we're using right now a high-level programming language? Yes. So if we were to think about what the computer is doing, it would be much lower level and more detailed than this. In fact, each of these individual characters would be more concerning. We wouldn't be able to think about strings. We would be thinking more at character by character levels at a much lower level. So this is pretty high level programming. Great question. Can I explain the LOL example? How come the asterisk didn't take precedence? Good question. So I actually, that's a different programming language altogether. I think what I did was I started Python and I said, hello. I think I had parentheses around this, but I'll try it without in just a second and see if this still works. So hello. I think it was, or no, I think it was something like this. LO plus L string multiplied by 10. Okay. So this actually would take precedence because it's multiplication. If I tried to do this where I have the parentheses around the first part of this expression, we would see it has a different result. And so this did take precedence. That's why the L was repeated, but not the LO. And this was evaluated first, and then it gets concatenated with LO before it. Whereas if we use parentheses to more explicitly control the order of operations, we get a different result. Where do you find the link to class every time? So on the itinerary is where you're going to find the link to the stream when we're meeting synchronously, which will typically be Tuesdays. And then asynchronous outside of quiz days will typically be Thursdays. There are a couple of quiz days that will be on Tuesdays later in the semester, as the schedule shows, but that itinerary is sort of is the only place you need to look for what you need to be worried about right now. And as we get deeper into the semester, we're going to reorganize it a little bit so you don't have to scroll way down. So we'll have the most important things at the top. But for now, just look at the itinerary to find out what you need to do. Okay. Good question. If you alter age, such as age is assigned age plus 1, is it automatically assigned to 36 if it were previously 35? Yeah, it'll take whatever its current value is, add 1 to it, and then update it to being that. So if you referenced it later, it would be 1 plus whatever it was prior to that statement. Why are colons used in defining the first variables while renaming or reassigning one variable? There was no colon. So I mentioned this earlier, and this is a great last question to close on. There is a difference between when we first declare the existence of a variable. So we're saying, we're defining the word name to have meaning in this program, and we're saying it's going to be bound to this type string. And later, we're still referring back to the same name, right? So VS Code actually gives you a hint here when you double click on and you select a variable name, it highlights all the uses of it. And so the second time we're saying, hey, go build up this more complex name, or same idea here, take the previous age and add 1 to it, and then reassign it back to this variable that we've already defined. So the first time you define a variable, you'll say what type it is. And thereafter, if you want to change it, so you want to increase its value, decrease its value, or if it were a string, you could concatenate it to be a longer string, or just change it. You don't have to repeat that type. It's already been defined beforehand. All right. These were fantastic questions. And for those of you who stuck around, I appreciate it. You'll get an email from me very soon with the more specific list of subjects, but be sure that you get the diagram submitted. We'll have office hours tomorrow, and we'll have Kaki's review session tomorrow. So if you have conceptual questions on anything we've done, come see us and work with us there. There's no exercise that's going to be due before the quiz. There will be that one video that I'll post that has some more of the sort of nitty gritty on variables. So some of these other questions will be addressed in a more detailed fashion in that video. Have a great rest of your Tuesday, and yeah, see you for the quiz on Thursday.